I'll be solving Leetcode problem 2863. Maximum length of semi-decreasing subarrays. So we have integer array nums, and we return the length of the longest semi-decreasing subarray of nums, and 0 if there are no such subarrays. The subarray is a continuous non-empty single. Okay, so we need to find the longest semi-decreasing subarray, meaning longest subarray that has first element strictly greater than the last element. So if we have like this one, it's 7 and 6, as they say here. Here we have 61 to 60, so 61 to 60, and so on. So this is pretty interesting one, but so this one has interesting approach. So first what we are going to do is have a stack. Yeah, this will be just a stack, and we'll go, so for I in range maybe I get 10 is one of nums. For I in range n. So if not stack or stack of -1 is less than or equal, or so nums of I strictly greater. Do I want it? So I go from left to right. Do I want to have the exact same? Actually, I don't. I can have it, but I don't need it. So I want it only if it's greater than what's on top of stack. And in this case, I append I. So with this one, we have a stack containing indices of values of nums in increasing order. And so essentially this will be our left index. We'll see how exactly. Now in this one, so we'll just initialize the answer, and we'll go from right side to left. So for I in range n -1, -1, -1. So what do we do? So while there is something on stack, and so stack of -1 is greater than, so strictly greater than nums of I, but this is my bad, so like this, nums of stack -1 is strictly greater than nums of I. if this is true, I will try to update ans. So I have max of ans, and so since this is the rightmost and this is the leftmost, it should be I minus stack of -1. And I pop from the stack. Wait a minute, so 1. Am I off by 1? Off by 1, 0. Okay, I'm off by 1, but let me see why. So I'll have a length, and if I is, let's say, I in this case will be 6, and stack of -1 will be 0. Will be the 7, so this is 0, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7. Okay, so it has to be +1 here. Try to quick submit. Okay, it works. So I'll build upon this one. Let's also do first, just try to time complexity and so what essentially are we doing? So here we put, we build a stack of, let's forget about indices, but stack of values in increasing order. And then we go from right to left and check if that what we have on the stack is potentially in what we have at index I. Does it build a valid stack and valid subarray? So, and it will build a valid subarray if that on the top of the stack is greater of nums of I. So how do we know that this is left of nums of I? Well, we can be sure. We can't be sure. Maybe it is exactly I. But if it's I, then we'll just shoot it through. In this case, maybe I should have used even equal signs. But if it is I and it's equal, this won't run and we'll go to next one. Next one will be, let's say, 11, or let's say this is 10. But next one can't be. Yeah, that's the idea. So essentially, next one can only be smaller. So if it's smaller, that's like, let's say 9. Yeah, I was giving wrong analogy. So it can only be smaller since this one. So let's say it's 9. And because if it's greater than this wouldn't be on the top of the stack, but the other one would be. So let's say we have 11, 11, and then we have 9 here. So this is 9, but this I is less than this one. When you do the math here, it will be 0 or -1, whatever. But since it's since we are maximizing answer and answer is 0, this works. So it's not that easy, but once you understand that with this building this stack of increasing values, we essentially make sure that we only consider the, let's say, the correct ones. And when we like let's say get a number that's pretty low. So this is 11, and the first one is, let's say, 3, the zeroth element in the stack, and nums of I is, let's say, 1. This will go through, but then it will stay in the while loop and will pop until we have correct answer. If we still have like valid answer, we'll just continue popping and updating answer. And why it's okay to pop? Because so if the condition is satisfied, this is the rightmost, this is the biggest, the longest, the highest length is this distance between these two. So if we decrease by 1 this one, it will be only lower. So that's why we can pop without the problem. So yeah. Pretty condensed, but the idea isn't that simple in my opinion. I struggle with this one a lot until I got to the answer. So yeah, I hope this helps you. If you have any questions, leave them in comments, and thank you for following this one. See you in the next. We don't see you in the next one because let's analyze complexity. So should be, I would say OFN for the space complexity, OFN for this one. But in the worst case, if it's worst case, I think it's OFN. Not sure. Let's see. Maybe OFN squared. Yeah, OFN. This should be correct. OFN. Yeah, it is OFN because if it's there is no worst case because we decrease rapidly, and once something is out of this, it's gone. Yeah. Yeah. Okay. That's all I have. So, folks, see you in the next one.